Hey guys, welcome back to automation. We're going to get back into those tutorials and we're going to start on the second one, tutorial on engine reliability. So guys, what has happened on this is we have been approached by a company that already has an engine. They have made a super powerful engine that flies apart, so it's a cost cutting. So they've made a really powerful engine and they've made it really cheap. So what they want us to do is make the engine still maintain a certain level of its performance, but they want us to bring up the reliability and they want us to make the engine run smooth. So let's have a go and see what we can do with it. Let's have a look at this engine. So twin cam, 3 litre. So it's a 4-cylinder inline 3 litre. So that's got some big pistons in it. The thing is, guys, when you have big pistons or you have a long distance, so the bore and the stroke, so the bore is around this and the stroke is the length. So when you have a piston either travelling a big distance or with a big bore on it, a big head on it, that's a lot of moving weight. So obviously, like, you know, the heavier something is and the more you spin it around, the more it wants to pull you over. So like when you see those guys in the athletics with the hammer throw and they get that hammer out there in the ring and they start spinning around, if they get off balance and then let go of it, they often get thrown onto the ground because the weight of the hammer overcomes them and pulls them over. So that's what can happen with these engines when you get big pistons moving and they can start to go for it and then they get thrown out, and then you have a case called a leg out of bed when the conrod comes through the side of the block. So the engine destructs itself. So ways we can accommodate that is they have, what have they got options for us? We can change the stroke, so we can make the distance of those pistons, the distance those pistons are travelling less. We can't upgrade the materials. We can change the crank. We'll see how the crank goes, that might be an option. We can upgrade the conrods and pistons. And then we can do the compression. We can't change the variable valve timing. We can't change the profile. Can't turbocharge it. Play a little bit with that. We could bring the RPM down, which our first step will be, is because 8,000 RPM for an engine of this size is huge. So we'll bring that down. We can't change the exhaust, so that could be a bit restrictive. So yeah, like I said, the RPM was really high. So by bringing the RPM down and just how much those spinning parts are moving, we've instantly reduced some of the fatigue on that engine. So not enough though. So still in the top end there, we're just starting to get a bit of engine failure. But looking at this curve, we could probably take a little bit more RPM out because it's not starting to drop too much. So we'll rerun the test. Still not great, we're still destructing it, the top end there. So just wind a bit of the stroke out of this thing. It's obviously going to decrease the horsepower, but it's just going to we're just going to limit the distance that those big pistons have to travel. And there, that's all we had to do. So we just had to get those moving parts to not be moving as much, and we have success. So all that was about is taking the moving parts and making them move less. Okay guys, so in this this tutorial, it's all about fuel economy. So we have to make a green vehicle. So that means we have to keep the performance index at a certain level, being 40, and we need to have a good economy above 560. And then we also need to have the emissions to be less than 375. So we'll look at the ways that we can do that. So once again, let's just check out what we have. So it's the year 2000, as we can see up here, and this car is still fitted with a carburetor. So the carburetors are not fuel efficient because you're not getting the mixture, the air and fuel is not getting mixed to the most effective amount. Obviously carburetors are very cheap to build, but they're not efficient. So that's the first thing I'm going to look at doing, and that's it. Done. So guys, let's just have a quick look at the different options here. So we have got the carburetor. So they have a single barrel carburetor, which is a very small, very simple carburetor, obviously very cheap. And then we go to a 2 barrel, which just allows a little bit more fuel. We've got a 4 barrel. Once again, even more fuel. And then a DCOE. So these are normally like a side draft carburetor. It's just a down draft and a side draft. The most efficient sort of the carburetor styles, but yet not as efficient as a computer. So we've got a mechanical fuel injection. So it's got a little fuel pump. This is a sort of system that you'd normally see with like a diesel vehicle. Single point, so the fuel is introduced where the carburetor would be. Or multi-point. So we've got the fuel rail and it's injected right in by the cylinder. And then we can go per throttle body. So they're individual. So the manifolds are all individual. Instead of just having the singular one with the coming into each cylinder. The air filter brings the air in off the airbox to the individual cylinder. So it's not the air is not getting interfered by the other cylinders. So there's a fuel rail which has got the fuel fed into it, then each individual injector controls it, and there's a fuel pressure regulator, so that controls how much fuel pressure is in the rail. Once again, so that's how they can make it so efficient. Anyway guys, I'm just rambling on. I think that will do us for this episode. I hope you guys learnt a little bit more and got to see a little bit more. As always, we'll do a little bit more and then we'll see a little bit more next week. Remember guys, links on ways to support the channel down below, and make sure you subscribe so you don't miss out on the next episode. Thanks.